Yes, I promise that we will put a lot of energy in our message so you don't fall asleep. Yes, and a part that I'm very sure that what we will be sharing with you today is it has a lot of value because I'm not gonna come to tell you what you could do. We're gonna tell you what we already did, how it works, and how you could benefit from this information. I brought today for this presentation my colleague Cuba. Don't ask me how to read his surname, it's over there, yes, I wouldn't know how to read it. He will be presenting one of the parts, an amazing project that he is currently working on, and I think that it's the best that he introduced the project. So I started doing a lot of R&D. I was very lucky to work for universities, to get recognition from the European community, to do research. But then I realized that whatever you could build as an R&D person, it was very hard to really get to a final stage. In R&D, you don't know how to deploy. You have amazing solutions in your laptop, but then when you want to give them to IT, they wouldn't know what to do with that. Yes, and during the design phase in R&D, they wouldn't know how to design it in a way that could be scalable and it could be deployed without issues. So I got the opportunity to work for IT organizations for, cool, thank you. So I got the opportunity to work for IT organizations on the innovation side, and I think that I found my place because I got to design, build, and put it into the final customer. So for the agenda today, yes, I'm going to introduce a little bit, which more or less what I'm doing right now. I will talk about my company. You will need to give me these 2-3 minutes. So they are sponsoring me to be here. So I need to tell you what opportunities we offer for you if you would like to join us. Yes. I will share with you some information that I'm collecting connected to machine learning in Industry 4.0. And then finally, the most valuable part, the real problems. I will share a little bit about my PhD and how pieces of my PhD I've been using it to implement it in real world solutions. So for the companies I've worked in the past and for the company I'm working right now. So a little bit of ArcelorMittal. Hope the audio. No audio? Maybe use my laptop. So no worries. So basically in this video, the goal is just to show you that the audio is on this side. I can help you if you want. Yeah, it's fine. So basically, ArcelorMittal has 6 factories. Everything is huge. Everything is massive. They are producing everything that is connected with the steel, even from the extraction and preparation of the raw materials until you can make actual pieces for cars. Well, we deliver the metal or the laminates, the coils that they are being used to make cars and many other products. You can go to Prasuipl, yes, where you will see all the offers. There is a lot of chances. If you really want to solve problems, if you really want to change something, if you really want to see how the past of Poland looks like and how we are trying to make this looks like the present of the war, so then we have a place for you. There are many opportunities. The company offers you a lot of things, and you are welcome to apply if you see something of value for you. Yes. Then a little bit about myself. I'm originally from Venezuela. I moved to Spain. I graduated as an industrial engineer, specialized in electrical engineering. I did many things. I spent in many countries doing some jobs. The more relevant I work in a small shipyard. I wanted to do some hands-on job before continue doing research. Then I became Marie Curie Fellow in a project called Energy Smart Tops. I finished my PhD in multi-criteria diagnostics of electric drive. I became the first data scientist in GE Healthcare. I built for ABB. They gave me a very long title, the chatbot platform, and now I'm in ArcelorMittal doing Industry 4.0. As you can see, I've been shifting all the possible areas within data science because I got bored very fast, but I actually used to keep learning. So companies are still paying me to learn so that then what I learn, I apply it as a solution. So that actually is an opportunity if this is something that you like. When it comes to the history behind Industry 4.0, I think that all of you know this, but what is important is that there is a shift and it's a big challenge because not so long ago, 10, 15 years, companies did a big investment in this Industry 3.0. So they finally connected to internet or to a network, a lot of robots, a lot of machines, yes? And now there is all this new idea that you need to, again, make a total new investment to enable industrial Internet of Things, to enable machine learning, because all of this was created from the controlling point of view. So how you can control all your machines, all your robots from a remote control room. And now so what about the data? Yes, so the existing systems or the shift between what it was existing and what is now Internet of Things, Industry 4.0, is based on the fact that now data is important and these systems, they are not able to handle the data. So it is important, this technological shift. Yeah? So if you see the areas in which Industry 4.0 is looking at, so we have from many different areas, from many different players, from even governments or companies. Each of them, they have a definition, yes? So each of them they will tell you what Industry 4.0 is. The fact that Industry 4.0 is what I just told before. There is a need, or there is an understanding now in the companies that data is extremely valuable, and now they don't have the tools to process this data. So Industry 4.0 is the name from my point of view. You have all these definitions that I believe they are also valid, yes? But from my point of view, Industry 4.0 is just how you can modify the assets in a company to make value from the data. If you see a little bit what can you do with Industry 4.0, you can support or make your robots more advanced. This additive manufacturing is something that taking the hype of 3D printing, so Industry 4.0 is also talking about that. Augmented reality, simulation, horizontal vertical integration, industrial internet, cloud, cybersecurity, big data and analytics. Yeah? So in all these areas, there is a lack of skills, there is a lack of people that is really capable to understand all of this. So if you like any of these, yes, go ahead, try to study by yourself as much as you can, and you will land in a job connected to it very easily. Because most probably the person who will be interviewing you know less than you. So Industry 4.0 is also a very nice opportunity, yes, to work in innovation and also delivering solutions. So now let's focus on a little bit more in the data analytics part. Yes, it's some kind of like an accepted situation, condition, yes, that 70% of the data is just garbage. Yeah? It's just simply worthless. Yeah? The job as working with machine learning and artificial intelligence, how you can really get that 30% and make your company make more money. Yeah? In the end, it's not about you having fun building models, which is also okay. It's you making the company to generate more revenue. So how can you do that? Yeah, so what companies need, or where are the areas that we can help? Yeah, so historical data collection. There is a lot of historical data, and it's very hard to get to it. The Internet of Things, in theory, is solving the fact that you want to connect your systems to real-life systems, and you would like to collect this data. It's a big challenge, yes, because basically not due to the sensors. It's more about how do you really transmit these values, this data in a reliable way. Data aggregation, feature engineering, connectivity, these gateways, integration with PLCs. If any of you is doing here industrial automation or anything connected to PLC, I'm very curious to see what is going to happen in the next 5 years connected to PLC, because for me, they are really slowing down the innovation in industry. Finally, if you want to work with data, you need to accept the fact that you also need to do a little bit of BI, which is you need to create reports or monitoring reports that will basically allow people without the skills to process the data to understand what the data says. Once you can handle all of this, then I believe we can be ready to do artificial intelligence and machine learning. Security is extremely important. Be sure that, your company won't lose money with what you are trying to do. Finding colleagues or finding people that can actually be part of the team and can add value. And privacy, you never know if something that you are doing will violate any privacy law. These are the challenge, yes? Apart from the existing challenge of how the data brings so much low quality or low information value to a given process. How I see Industry 4.0 is use a mix, and in my case, this is where we're focusing now, is where we're trying to help our factories to have automated cranes, where we are trying our factories to move 30-ton things, 40-ton components, materials, even bigger, yes, in a smart way with minimum risks for human. This is one of our focus. How we can use computer vision, how we can make this a skill for a crane, for an operator to work better. Yeah, so we have to install a lot of cameras everywhere, yeah? How does it look from development to deployment, yes? So someone has to have a concept, yes? So one concept could be how we can automatically recognize trains, yes? One of the problems I will be showing you how we solve it, yes? Which we did a hackathon for that, by the way, yeah? Then you design. You start, you take a marker, whiteboard, and you start to put ideas there. You test and evaluate, and most probably here in this moment, you will go back and reevaluate your concept, yes? Finally, when you are happy, you will need to take it to production. This is very, very complicated, given the fact that, that deploying a model, yes, that will never fail today is a challenge, yeah? It's a real challenge, yeah? So you can make something that works in your computer very nicely. You can put everything in a Docker. You will be able to deploy your Docker somewhere else, but there will always a data type issue. There will be always a float value coming from somewhere that you never expect, and your machine learning model won't work. And there is no value for any company that you have the best model if you cannot take it to production. So then, this is why it's very important that we break a little bit the mentality that IT doesn't go to operation. You go to operation, you work with the operators in the manufacturing area, yes, so that finally you have a model that if you weren't capable of preparing the model to don't fail, at least will accept retrofit so that it can update by itself and ideally get better, but realistically speaking, that doesn't break, yes? This is true. I've been working already 4 years presenting this slide to my managers, and let me show you some projects. So first of all, a little bit of my research. Electrical machines are everywhere. Basically, they are the primary movers of every industry. Yes, so it is important to understand if they are going to fail. Traditionally, you have a data acquisition system. You have a lot of smart people working with MATLAB doing signal processing to generate features to finally define a condition-based monitoring. Ideally, we create a digital twin. So it's a system that behaves as close as possible to the real system. Yeah, and finally, you can do data-driven decisions. For my PhD, I had a data acquisition card. I didn't work with PLC. Yes. I collected for 10 cases, 9 fault conditions plus the healthy condition. I was able to destroy motors to see what were the patterns on the signals coming out from the motor. I even designed my own data acquisition device, yes, in which I was able to collect up to 38 signals, yes, 37 sensors, and I was collecting 38 signals at the time. This was the 38. I was able to do the signal processing, and to do that, I create 5 groups. Yes, so I process 1,224 features out of my 37 signals that I group them into the clock transformation. This is something very specific to electrical machines. Part transformations, some features extracting, exploiting the relationship between voltage and current, and frequency analysis. Traditional systems that analyze the faulty machines, they are relying on FFT and Fourier transform, and also 777 features that I simply took from statistical functions. I did a lot of feature extractions. I did a lot of modeling to recognize how much information each of these features contains. I have to do L1 penalty and L2 penalty using ElasticNet. So I was able to identify the biggest contributors to the variability in my signals, and the ones with bigger discriminant factor for each of the classes I was analyzing. In a simple Intel Core i7 60 GB of RAM, I was able to process almost 1 terabyte of data, like in 1 week. Finally, using sparse linear discriminant analysis, I was able to rank for each of the classes that you see on the top. Yep. So these are the classes, and something that all the professors at university, they already knew. The algorithm was also able to find it by itself. So that means the algorithm demonstrates the capacity to learn and to measure how to discriminate the information coming from all the sensors. Of course, after that, we no longer need 37 sensors. We only need the sensors that are needed to build these features. Finally, I just plot my 3 most important features. You can see that all your points, they arrive into one plane. So that means that in that plane, that represents one of the nominal conditions during the operation of the motor, yes, you can see what is the condition of the machine. And I still didn't get to the part that I could do prediction, but I know that with some equations that I cannot disclose, I know when we can stop the motor before it's catastrophic. I know how we can decrease the load of the functioning of the motor to at least allow to finish some of the processing in case you have some material already during the normal operation of the motor. Yes. So it took me 1 year to build the laboratory, 2 months to destroy a lot of motors and put a lot of sensors, and 1 year until I go to the whole processing. Yeah? I was very lucky that I was able to fully dedicate to it. Yeah? Finally, I train different models to classify these features. So as you can see, they are very, very, very good results. And it's all based on the fact that electrical motors are symmetrical machines. Yes? So if you train the motor from the CERN machine, so the asymmetries that are present on the machine are known by your model, then you can achieve this type of accuracy. In reality, if you take my model over a new machine, you will need a couple of months of data, yes, and at least some data points on some failures that someone highlighted, so for the model to be able to adjust and get to around 80%, yes? The thing is that what is more important in electrical engineering is that you can evaluate a new observation very, very fast because the motors are at least rotating to in 1,500 revolutions per minute. So when a fault appears, it tends to be very fast until it gets catastrophic. So we can sacrifice accuracy by increasing on the speed on the fault detection. Anyway, this is a lot of theory. This is laboratory. One of the partners of my research group, one of the companies, they are taking and they're building products using this use as a reference. I'm not saying that I got all the answers, yeah? But we were 10 guys researching on the same area. So finally, you can see the confusion matrix. So we can see where the model is struggling, yes, and actually, due to the fact that the machine has inertia, it goes counter the logic. So you will assume that when it's a bigger amount of current deviated generating the fault, you think that the patterns that define that condition will be more visible, but in fact, because we're talking about big machines with big inertia, it was the opposite. The model had bigger success when the fault was starting rather than when the fault was a little bit more critical. So how we're doing, or how am I using this knowledge to help ArcelorMittal? This is massive, you know. This thing that is here is just a model, is as big as this area. Yes, so this is used to, before you are doing the casting, so before you make the liquid metal to become a solid thing, yes, you need to move this to certain angles to pour some of the components, to pour also the hot metal liquid. Then you need to rotate it, and the fact that you need electrical motors to do that, the fact that you have bearings, yes, that they constantly suffer because in a given position, which is always normally the same, is being loaded, and then from a standstill position, you need to rotate it, yes, there is a huge need to understand how this repetitive movement is degrading some of the bolts in the bearings. And one of the solutions, for example, after we analyze the data, is that we could try to do time to time, I still don't know when or how often, we could do a full rotation. So it's like we make the spheres inside the bearings to change the position. Yes, so we are not constantly squeezing always the same face of the sphere. Then our colleagues, yes, this is I'm just here showing their job. For the last 1 year, they created a network that connects some of our factories, yes, using LoRa. For those of you who doesn't know what is LoRa, LoRa is just a wireless protocol that without having to pay anything to anyone, if you have your antenna and you have your devices, emitters or receptors, yes, you will be able to transmit the information. Here you have some meters. We are starting the deployment, measuring the water consumption, the electrical consumption, yes. Also with LoRa, we are tracking how some of our trains are moving But now we need to do software development because, as you can see, it's not really following the proper road, yes? So by software and by also image recognition, we need to try to fit, yes, the points to the most realistic point on the path that the train can follow. We're using deep learning to do wagon recognition. This is what the task that we did in a hackathon November. There we shared a lot of data using an old system, using some kind of analog cameras, and all of you help us to take the decision that we need to renovate the cameras. This is how the project looked like. This is a real project, and of course, everything is delayed, because that's the reality, yes? We not only focus on doing programming, we not only focus on creating the model. I had meetings with the guys that sell cameras. I had to really listen to them, yes? I had to test the cameras. We had to go to the field, install the cameras, come back, and again, and again, and again, until we had to take the decision which cameras to buy, until realize that we didn't have network, until I realized that we have to help our colleagues to build the network, and so on and so on. So fortunately, companies like ours, there are teams, yes, and everyone is helping. But as you said, in the end, most of the time, it's not really the programming. Actually, after the results we collect from the hackathon, we got very good ideas, and I just put all this together. And now, following the idea that we first recognize when a wagon starts, when a wagon ends, I'm sure that you remember all of this, and I see other faces, familiar faces here, yeah? It's possible to segmentate where the digits are. I'm using YOLO. I prepared all this slide trying to explain you what YOLO is, but I'm sure that all of you know it. Basically, you segmented the image, you score the features that the algorithm is able to extrapolate from the image, and finally, you know what is a dog and what is a bicycle. In my case, I know where the UIC code is, I know where some other metadata associated with the wagon is, and I know when there is a gap between two wagons, so I know when a new wagon starts and when a new wagon ends.